I always like to ask, do we have any Duolingo users in the audience? Besides my coworkers, of course. We had a few. Any long streaks? Yeah. Oh, that's a really good one. Much longer than mine. All right. So if you don't know what Duolingo is, our mission is to develop the best education in the world and make it universally available. We have a learning app that teaches you languages. We have 100 courses, and Irish is also on the list if you'd like to try out some Irish while you're here. All right, we're going to start with a philosophical question in tech. What is a cloud or the cloud? So I asked this recently. This was the consensus. I always like to add this to it, though. You know, it's computers running VMs, more or less. Today, we're going to be primarily talking about AWS EC2. I'll mention some other clouds in a single slide. But yeah, we run mostly on EC2. So just as kind of a primer, what is an EC2 instance besides, you know, a jumble of letters and numbers? So to start off with, we normally have a family, which is, you know, the type of instance that you're working with. Is it compute heavy? Do you need lots of memory? Do you need lots of disk? And then the generation, which is typically the generation of the processor. It just increments. And now they've started to add the architecture, which we'll get into. So I stands for Intel. I think that's pretty straightforward. A is for AMD. And then there's D for disk. If you want a local disk to write to, we use it for ephemeral logs and just kind of random data that doesn't need a persistent disk. And then the size often confuses people because the X is a multiplier. So 2x large is actually 4 times the large instance, which is 2 cores. So we have 8 cores here, and then the memory also goes up 4x by then as well. Recently, AWS has gotten a little crazy with naming. I always get a little scared when things start looking like Unicode. I don't know about you. Yeah, the T is for like terabyte. There's some really wacky stuff in here. Extremely expensive instance, obviously, 448 vCPUs. We don't use this one. Let me know if you do. I'm very interested. And if you ever wanted to look up this information, I have a link at the bottom there. The vantage.sh site is really, really good if you're just looking for a particular kind of instance. All right, so we're talking about costs. So how do you purchase these things? So on demand is the easiest. It's list price. Doesn't really change once it's released. And then we have reserved instances where you get up to 75% off on-demand price with a 1 or 3 year commitment. And you can also sell them later via the marketplace, although the fee is really, really high. You typically want to avoid it if you can. And then spot instances, which we're going to focus on the most in this talk, comes from spare capacity on AWS. And you get up to 90% off on demand. But it could shut down within 2 minutes with a warning. So some trade-offs there. Also, one of the newer options is savings plans where you just commit to a certain amount of spend. You're not committing to certain instances. So, and again, this is all up to the percentage. These highest percentages are rare, as you'll see. So the spot market. There's also a lot of confusion about how spot pricing works. So it's pretty easy. You bid on the maximum that you're willing to pay, but when you get the instance, you pay the market rate. It's not that you're paying the price that you bid the entire time. That's actually how it used to be prior to 2018, where the prices could go like way above on demand. I don't know if any of you remember this era, but there was high frequency trading and people spinning up enormous amounts of compute, and they would just steal all your instances and it'd be really hard to get one. And the market has been relatively stable ever since. Yeah, there's something coming. So how we deal with these things at Duolingo, we don't run on Kubernetes, we run on ECS. We don't have to deal with control plane upgrades, thankfully, as a result. But we use this service called Spot.io, which kind of controls all of these mixes of things. So we have RIs in the mix, we have savings plans, and we have spot instances, and then also on demand when we need additional capacity, we're willing to pay that extra price. So as you can see, we're pretty heavy on spot. One of the advantages of this is we kind of have built-in chaos testing. So our services, need to be pretty resilient because machines shut down all the time and auto scale. All right. So at the end of last year, we finished switching some of our largest services to Graviton, actually. And you can kind of think of Graviton as AWS's version of the Apple M1. It's custom silicon, only Amazon has it. It's kind of a good way to do lock-in, although other clouds are coming on to ARM instances as well. And it has really good price performance. So just looking at apples to apples, on demand, you get 20% off the equivalent Intel. And we found that the performance is roughly equivalent, within a few percent. And then the other big advantage is you get real cores. It's not hyper-threads. So if you have a multi-threaded application, you might actually see more performance benefits. So we went through this whole porting process beginning in the summer of 2022 because we were seeing supply crunches on the Intel instances that we were using, both in the spot market and also on demand. So we had machines just spinning down like all over the place, and it was too much chaos. Like our services couldn't handle that much interruption. So I kind of think of this as like kind of the first signs of things that are to come. But yeah, by the end of the year, we were on Graviton. Finance was super happy. We actually saved around like 45, 50% in total because we weren't running as many on demand. We were back to spot. And there seemed to be lots of Graviton instances on the spot market at the time. So we were in good shape. So again, why this talk exists. Things changed. Markets are unstable, really? Who would have thought? All right, so this is what we saw. And we're looking at Graviton here because this was the hardest hit instance type, but there were also changes with other instance types for Intel as well. And we noticed around halfway between March and April, I'd say, like something is going on with the cost. But we were also making a lot of different infrastructure changes at the time, so it was kind of hard to see what was happening. But as you can see here, we had initially 60% discount, give or take, and then suddenly we're almost at 0%. It was like a few percent discount. And at that point, you might as well just buy RIs or run on demand. So AWS has a tool where you could view individual instances and see the top line there, which is obscured by the actual price because it's right at it, is the on-demand price. And you can see very little discount. Less than 1% in some of the AZs. Not great. So who else noticed? We were wondering this ourselves because like surely there would have been some sort of article about this in April at least. So the only things that we saw initially were in private Slack channels, and also there was a tweet in late March, and that's basically all that I could find, which is interesting. And then we started seeing kind of academic type articles coming out in May. One showed a quadrupling of interruptions in a 10-minute period. Not a great experience. And then the majority of the instances still have 30, 60% savings. The fourth one saw, but the instances were much older and less performant, so we typically don't want to use those ones. So other clouds. Azure actually experienced a really large increase as well, 108%, and 21% on AWS on average. And then GCP actually experienced a decrease. So if you're on GCP, maybe you made out. And I have links to all these articles. If you're interested in this, definitely check them out. They're great. So what happened? I mean, no one really knows. Someone in Amazon, I'm sure, does. But here's some theories I have. Again, this is all speculation. I don't know for sure. So many companies, as you know, are becoming cost conscious and moving workloads to Spot and Graviton. Actually, I know for a fact this is happening because Amazon is saying they're helping customers do this. But then I started thinking about this Prime Day article here where Amazon was suddenly running 2.7 times more Graviton instances. And that's probably a really large number, right? So are they stealing our instances? I don't know. Not saying anything. So is another large AWS customer bringing on more capacity. And actually, I've seen some other large customers of AWS present on this topic as well, where they moved everything, tens of thousands of instances plus in some cases. So that's also very feasible. And then is AWS also like trying to cut internal costs? And are they running out of physical machines and not replacing them over time? So how do we visualize this? How do we get the full impact, at least like per region? So Spot.io actually gives us per AZ metrics here, and this is kind of useful, but we're kind of limited to a certain set. So we turn to GPT-4, which we were using internally at the time to develop Duolingo Max, no relation. You could check out our blog post here if you're interested in that feature. But yeah, we had access to it internally as a chatbot, which was really nice. So I was trying this out. So give me a bash script that lists all the current on-demand and spot prices for all instance types in US East 1. Because I had no idea how to grab this information and parse it. It becomes very, very tedious, right? So the first one seems to be grabbing the on-demand, at least the comment that was generated there. And then the second one is spot prices. I highlighted some things, kind of weirdness. So this is what we got. This is my first attempt. So first of all, it's in an ASCII table format. That's kind of weird, right? That was here. And then you look at the actual data. There's nothing there. It's all nuns for on-demand. So what happened? So it turns out this is actually completely non-existent. This is hallucinated code. Doesn't work. All right. Next run. This looks a little bit more promising, right? So there's JQ in here. So good. It's like parsing JSON. Maybe it might be good. Might be real. And then the spot command is pretty much the same, but here in both cases we have JSON output, which is much more useful, right? And this is looking better. This is looking much better. This is actually the data that I used. I dropped in a spreadsheet, and you'll see the graph in a second. There is some weirdness here. There are zeros for some of these. If you want to know why, talk to me after the talk. It's a little bit complicated, but it's fine. This one actually works. All right, so we have a scatter plot here. I have instances in alphabetical order. Don't try to find any sort of trend line here. It's alphabetical. Maybe the only trend is Amazon starts using U's and X's and Z's as things become more bespoke. That's about all the trend here. But we're looking at kind of what's in the middle between 25% and 75% discount. And then we have these ones way up top, which we'll talk about here in a second. But quickly, like lessons learned on GPT-4, non-deterministic. You run it multiple times, you get different code every time. Obviously, the generated script quality can vary quite widely. And then you also must kind of have domain knowledge, right? To kind of throw out the garbage with all this hallucinated stuff coming in. But in my opinion, as a templating and autocomplete system, works pretty well. It gets you pretty far, with pretty much zero effort. All right, so how do we survive this thing? I could talk to you about, what we're doing. There are actually some very good glimmers of hope as of this week. I had to update my slides because of this. But you can see beginning of October, the prices actually started decreasing for some of these larger Graviton instances in some AZs, not all. So that's just 2 there. But yeah, I'll take 20% off given 0 before. And then coming back to the scatter plot, this is also updated as of this week. Really interesting, at least I found this is super interesting. So you see some of these really, really old instances. So these are like the original Intel instances, the C1s, the M1s. But we have C7A, which I hadn't even seen had come out yet. It came out within the last week. And this is the newest generation AMD EPYC processors. And then also the memory equivalent of that at the R7A. And this one is actually a bare metal instance where you could run your own virtualization. So this is 90% off. So this is great if you can deal with the interruptions. So just to wrap up, some possible survival strategies. These are just kind of my recommendations based on experience. If compute costs are known and relatively fixed, you should definitely be using savings plans as kind of that base load. If compute costs are variable, kind of how this graph is down here, this is one of our compute clusters. You should probably be using convertible instances, especially if you want to upgrade to the latest generation at a later time. And then you should really diversify, like any sort of financial market, right? Use large and small and different sizes. And then also, you should start looking at potential savings elsewhere. If you're relying wholly on compute savings and not looking at anything else, maybe start looking at other stuff. I mean, we did. All right. Thank you.